Yeah. Thank you everyone to join the sessions. And this is going to be part 2 of NSX-T. Um, and in the previous sessions, we talked about the basic layout of NSX-T, how we implement the solution, and how we install the basic manager and controllers. We've gone with the basic
Getting a lot of
glimpse
noise.
of. I'm sorry, like this. Uh,
Can you
Palak,
mute us?
can everyone like mute? There's a voice that's coming up. Perfect, thank you. Yeah, and obviously, like if you have any query, just you can unmute and then you can actually put your queries. Yeah, so what I was discussing last sessions, we talked about, and we have done the basic implementation of the manager, which is going to be our control plane as well as the management plane. So there's a little bit changes from V to T. That is the one aspect that we have gone through. And we have gone with a basic glimpse of how the portal looks like of NSX-T. But today we are going to go into the detail of the networking aspect, how we define the switching platforms on NSX-T, how we do the routing, what is the changes we are going to see from V to T. That is one another aspect that we are going to go through. And on that basis, I've just created a basic slides. I don't want to give a lot confusion and more about more information on this slides what I have prepared today. As you might be knowing, like we have one test environment where we are already deployed NSX-T. So this is one of the test environment. I would say it's not a test environment. We have like a small production things which is being running, but that's fine. We have the controls in that. Just for the quick update, we have installed Federation. This is a kind of solutions where you can actually write down your configs from a single manager, and that can be replicated to a couple of your data centers. And to replicate one single data centers, I have deployed 3 set of managers just for the redundancy sake. We have already went through like what should be the better design. Obviously, we should place them into 3 different ESXi. Most preferably, it should be in 3 different racks. We have already configured the web regarding these manager IPs. So with the help of web, you will be doing all sort of configurations, which is contained within one data center. But if you want to do configuration changes in both of the data centers, in that regards, we do have solution called Federation. So this is a new product line from NSX-T again. We will go through Federation, but not today. Like let's contain ourselves within one data center right now and understand the basic things regarding how switching works and how the routing works. Obviously, we have some basic understanding how NSX-V works, what is VXLAN, and how we create any sort of VXLAN and how we enable the routing on it. But just for your information, we are not using the full features of NSX-V in the current design, what we have in our production. The point that I'm putting it out is the DLR concepts, which is a distributed routing concepts. But just to get started, I would say we in NSX-T can't go without DLR. So this abstract will be always going to be present with NSX-T, even though when you go with a vCloud Director or maybe with a native vCenter solutions. But again, when you talk about DFW only, like where we do microsegmentations, in that regards, yes, we can exempt the routing features. That is like same as like what we have in NSX. There's not much major changes that you could see. Obviously, there would be little bit changes on regards of writing the policies. We were writing in NSX-V. It's going to be a little bit different in T, but we will discuss those things in the next sessions. Today, we will be focusing more onto the routing and switching part. So on that basis, let me just go through the slides, and obviously we will walk through the technical configurations more in details, and we will try to understand what's happening at the back end of the controllers and what's happening in the ESXi. Obviously, this is going to be a good base for operation team as well as for the platform team to understand how the technology works and how we can architect it, and from an operation point of view, how we can troubleshoot it, and what are the abstract which we have to connect with each other. That is more like focused session that today I'm going to tell you about. So just to get started, this sessions will be purely on native vCenter. Though like we have environment of vCloud Director, which I'm going to cover in the later sessions. Why I'm putting vCenter more precisely, because until unless you don't understand the vCenter networking, it will be very difficult to understand the vCloud Directors. Because anyhow, like if you have experience with vCloud Director, it is basically going to use the baseline of vCenter networking itself, and somehow it makes out the things that to give a multi-tenancy kind of environment that can be done in VCDs. So let's try to make our baseline very strong with vCenter, and then we will move with vCloud Director, not in today's sessions, maybe in another sessions. So first and foremost, we have been always talking about SDN technology, and SDN baseline is to basically create VXLAN that we have always seen with any product line. It could be with the help of Cisco ACI, or could be from Juniper Contrail, or even with VMware NSX. So this is the first thing which is going to has to be seen in more in detail how this pieces works in our any set of environments. So see, like again, VXLAN is again a tunneling methods. No any major differences that you're going to see in T also. Only the back end tunneling taggings is going to get changed. So what I mean to say that the encapsulation part, what we usually do with any of the VXLAN solution, this time they will be introducing a new kind of tag called as Geneve tunnels. But again, from a backend technology, it is going to be same. It's going to be still called as a VXLAN. There's no any major differences there. So again, why we have a VXLAN? We are pretty confident about it. Why we should be having VXLAN? Again, just for any data centers, if I have to connect any VM to the another VM, not to go with VLANs, because VLANs will have some, not some, there will be huge number of caveats that we can't go through it. That's why like we have introduced VXLAN. That could be regarding the flood and learn technology, which happens in VLANs. Like everywhere you need to go with spanning tree, but we need to overcome from spanning tree. We have seen a lot number of disadvantages with spanning tree. So that's why like we have VXLAN. And obviously like in any cloud environment, you can't separate or segregate the traffic of any customer with the help of VLAN, because the number will be very concise. So you need a very bigger numbers, and due to the bit sizing of VXLAN, you have that possibilities. So this diagram, which I'm showing you right now, it gives you the detailed about it, how a VXLAN basically will be seen from NSX T point of view. So whenever we talk about any ESXi, which is going to be called as a transport node, but again, there's a huge differences again in T. You can't have only on ESXi, even you can run that same show on KVM platforms. So even you can prepare your KVM host to have and host VXLAN what you're creating with NSX-T. So you can have a mixed kind of environment. Obviously, I would say from a marketing strategy and even from a technical aspect, it is going to give you the true multi-cloud kind of setups. It doesn't matter that you just have a ESXi and then only you can run your NSX-T there. No, you can still run the show on the Ubuntu servers or in the KVM boxes. So that's the one thing. So again, over the top of it, we would obviously going to have any DVS. There's not major differences there. Whatever the DVS that you see in our current platform, the same concepts will be followed. But if you will take a look over here, we have NDVS and we have a DVS concepts. Now, what is the difference between it? Basically, the difference is that when NSX was like introduced, it always used to have its own DVS. Whatever the uplinks of the ESXi will be contained on NDVS, but this methodology was before 7.0 version. But with 7.0 version, you can still contain your DVS and NDVS stuffs within your DVS stuff. So you can actually have your VDS to support your NSX-T, VXLAN, VLAN, and even the native DVS, that is DVPGs. So that's going to give more flexibility from the design. So whenever we try to go for any kind of migration, it is recommended that we should be going with VDS concepts. And anyhow, like even though you can go with NDVS, but again, at later stages, you need to migrate it from NDVS to DVS. So that is one thing that we have to plan that way. But again, as in VXLAN, you would be getting a specific numbers. Just like a VLAN, you get VLAN 10, 12, whatever the numbers. But with the VXLAN, you're going to get a specific number, which is going to be extended all across to the transport node, what you have prepared on your VMware platform. So in a very nutshell, if I would like to tell that, if I do have an ESXi, and I'll take just an example of two ESXi, if I do have an uplink, so this is the physical NIC, which we call it as a PNICs in the concepts of VMware. And obviously on the top, we are going to have any network fabric. Now, obviously this network fabric could be anything, doesn't matter. But again, most of the designs like in data centers, they always try to go with on the top of another VXLAN, which can be given by native VXLAN solution, could be with Cisco ACI, could be Contrail, could be anything. But for us, like from NSX-T, it should be any fabric which can make these two ESXi to talk to each other. Now, in the previous sessions, we have seen that how a VTEP was created. VTEP is basically an encapsulation medium by which the traffic will go from one ESXi to the another ESXi. So obviously, whenever we try to prepare any VTEPs, it has to be contained into one segment. So which we will be calling on the top VLAN VTEPs. Okay, so that like all the ESXi's can talk to each other. That is the idea. Now, obviously, like for the load sharing stuff, you can have a couple of VTEPs and you can have a couple of NIC cards. That is also the possibility that you can have. So one of the VTEP will map to one NIC card and another VTEP will have the another NIC card. So this internal mapping will be done with the help of your network profiles, basically your uplink profiles. So that we have already seen that. But this is basically an infrastructure preparation. Okay, this will come into the infrastructure preparation, and it all depends upon what kind of ESXi blades you have. On that basis, only we have to define the uplinks in any kind of environment. But the show will start basically after then, like if any VMs, which is for a particular customer. So obviously we need to create a set of segment. So this segment is going to be called as a VXLAN, or could be Geneve, but doesn't matter. It could be any naming conventions. But what we are going to see, a VM will be there, like VM number 1. We are going to have VM number 2, and you can contain them into one single subnets. But the question is that how it is going to send a traffic from one point to the another point, basically from one ESXi to the another ESXi over an IP networks. So in the past, we have seen some another L2 stretch solutions, but it was not that feasible to be implemented into any data centers. So obviously we had to go with VLAN, and then we used to play with things with private VLANs. But it does have their own set of complexities. So that's why like we move with VXLAN concepts. So now if I do have a VM number 1 and VM number 2, and if it is a part of one set of VXLAN, they will be called into one set of segments, or maybe one broadcast domain in another sense that you will be seeing. So that's the figure that is being showing out over here. Like one will be called as segment. Then whatever the containerized application or virtual machines that you have, it will have a specific segment port by which it is going to identify which are the endpoints which is getting connected to our segments. So this is just a basic baseline what you would be seeing. The major differences that you're going to see from V to T will be more onto the policy side. Like you will have more flexibility now with T, where you can actually really change the backend policies, where you can tell that, okay, I want to flood that traffic. You have that option. You can provide a set of securities on a VXLAN basis. So that will compromise of your MAC management, switch security, spoof guard, IP discovery, and even this time the quality of service. I am not saying that in V we didn't have that option, but again, it was not that straightforward, and we didn't have these number of options. So we learned that things, and that's why these things were introduced in NSX-T. So under the hood, what you're going to see, a VM traffic will go from the another VM. All this traffic will go through the VTEPs. So it will be a basic IP packets of 2 boxes of VMs, but it is going to go through the ESXi and the VTEP as an another encapsulation will be put onto the headers of the traffics. And these traffic will go from one ESXi to the another ESXi. Now on the top of the network fabric, it will be just shown as that one VLAN traffic is going from one ESXi to the another ESXi. But obviously under the hood, it is just one customers or one segment traffic, which is going to go from one point to the other point. Now this process you have to really visualize in all across and every ESX size, like whatever the number of clusters that you have, you need to really think that, yes, it's going to happen on the backside of every VM-based traffics. So this is one thing that you're going to see in the logical switching. Nothing more extra, nothing more like rocket science things. But obviously, as I was telling, any VM packets will go from one transport node to the another transport node. Right now, it is showing as a production NDVS, but again, in our scenarios, it will be a DVS because we have the updated version of vCenter and ESXi's. So between one ESXi to the another ESXi, it will be a Geneve tunnels. And this is the Geneve tunnels, which is going to be seen in the IP fabrics. So as I was saying, how the traffic moves, it goes from one VM to the another VM. And when you look out to the segments, so this will be the scenario when you have anything below 7.0, where you will see every VXLAN as an opaque network. So again, VMware vCenter will still understand the concepts of DVPG, but this DVPG will be created by NSX-T, but in an opaque manner. It will be not contained into DVS, if you will see out over here. Now, this actually gives us a lot of set of properties which we need to understand when we will go for the migrations. When we go for the migrations, we need to really understand this part in more details. Like if I do have any current DVS, right? And we have a lot of number of DVPGs, and which we have, like which is defined for a particular VLANs. But if let it be, we are going to migrate anything which is lesser than 7.0. So we would be seeing that there will be NDVS that will be created. And this NDVS will claim to have its own uplinks. And all this DVS stuff will be getting deleted. Because NDVS is totally different to DVS. And this NDVS will be created on the ESXi levels. Now, why I'm telling that it will be getting deleted, because the VLAN or the DVPGs is only understandable to DVS things. It is not understandable to NDVS. So usually in these kind of migration, you have to create this DVPG in NDVS prior you do any kind of migrations. But again, this was one of the major issue or roadblocks for most of the migrations. Like you have to create that number of segments on NDVS levels prior that you do the migrations. But with DVS 7.0, this thing has got totally changed. Like you need not to go with NDVS concepts. You can still do configuration on the DVS levels. Whatever the VLAN that is there, it can still go on. And whatever the VXLAN will be created, that will be created on a DVS levels. So this is again a real good benefit. But before than that, like if I have an ample number of like a huge number of DVPGs, then in that cases, the automations will come into the pictures. Anyhow, like we can pull out the APIs, whatever the DBPGs that we have, do create that things on the NDVS level, and then do the migrations. If you don't do that, obviously you're going to see a traffic loss for a lot of number of VMs. So this is one thing that we were exploring when we were doing the testing of the migrations. Like it is good to have 7.0, but if you don't have, then obviously we need to really go through this stuff. So this is one difference is that you would see NSX-T on the DVS. You will see the port groups will be created on the DVS level. That won't be created out of a DVS things. So on that basis, let me just walk you through the lab, and then we will move to the routing part. So in my lab, I just configured 3 sets of controllers equivalent to management plane. So this time management plane and control planes are in the same boxes. And this is the NSX boxes, which you would see. And these are my 3 nodes, which is 3 transport nodes, which is equivalent to 3 ESXIs. Just to walk you through the configs again, this is one set of profiling that we have created that is on a cluster level basis, which is again equivalent to NSX-V. Whenever you create and prepare a cluster, and whenever you bring any ESXi, you need not to do the configuration that is going to be done automatically because that's defined on a cluster level. The same thing you can do even in NSX-T. But if you want to go beyond, like let it be, you want to manage standalone, you can still have that options. So this is one thing, but most of the networking stuff you would be going to create from a networking tab. And the construct which we were seeing in NSX-V was called as gateway. Basically, I don't remember. I think it was logical switch, right? So logical switch is basically equivalent to segments right now. So whatever you create, it will be called as a segments over here. But the major difference is that you're going to see segments. This can contain a VLAN based as well as a VXLAN based. So it does support both of the construct of your DBPGs. So what I mean to say that you can create the VLANs from NSX as well as even from your DVS level. You do have both options. But only the fact is that your cluster should be prepared in that such manner. So if I just go back again, and if I go back to my profiles, and this is very important to understand. So if I would see an active host uplink profile, and if I just click out over here, let me just edit it. So you would see so this is the profile that I have created, and that's going to define, let me just edit it this way. Yeah, this is the one that is going. Yeah, so in this abstract, what I have written, like we will have 2 sets of uplink, and then we will be load balancing with the help of MAC address. I think this is for host. Some changes that has happened. Basically, I had both of the construct, like I had like a VLAN based as well as a VXLAN based. Doesn't matter. Like let's go back to seconds. So if I go to networks, and let it be, if I have a scenario where I have to create a VXLAN for a customer, what I'll do, I'll just add a segment. So I'll write down customer number 1, and I'll write down segment number 1. Okay. So this is one segment. Now you have the next option, which is going to ask you to create a gateway. Right now, I'm not interested to create any gateway because I just want to create a logical switches, nothing else. I don't want to do the routing on it. Then the next option is that what kind of construct and what kind of transport zone it would be. So it's going to be a VXLAN based. So I'm going to create a VXLAN. You can define an IP, you can't define an IP right now because you don't have any gateways right now. Okay. So this is kind of a plain network which is going to be extended everywhere. Just save it. And what you're going to see, the same construct you're going to see in the DVPG. So right now we have 4 DVS. Let me just walk you through this one. Yeah, this is the one that we created. So when you take a look, you'll see that it does get one VNI number, and this VNI number would be created, sorry, like this VXLAN would be created everywhere. So basically, who does this configs? It's basically the controllers who write down this config on our DVS levels. So basically, to identify and to do the troubleshooting, we will try to go to the console level of everywhere. So let me just go and log into our controllers. So I'll just go to one of the controller. I'll just walk you through the commands so that it will be very useful. So whenever you go to NSX managers, you have 2 ways of authenticating to it. One is on the NSX mode and one is the root mode. Root mode we will be going to use only when it is more into the troubleshooting and you need to look out to the running logs. Right now it is fine. Now the commands will be more easy this time, not like in NSX V. In V, I would say personally it wasn't like that straightforward, the command and the verifications. So anything that you want to see out over here, everything will start with get. So we will write in get, and what you want to get. You have a lot of options. You have options like get all items, you get op table, blah, 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 maintenance. So I can look out to get cluster. You will be seeing cluster status, what's happening at the cluster level. So this is the cluster of your NSX-T managers. So everyone is up. If anyone goes down, it will be getting we'll be getting the notifications. So ultimately, it's going to do a number of things. When you take a look on data store side, boot managers, controller level managers, like different set of services which is being running. But for us, what is more important is to understand what number of VXLAN that we have. So what we're going to write down, we are going to write down get logical switches. So you'll see that how many number of logical switches that we created. So that number of VXLAN that you're going to see. So right now I'm doing some POCs. So that's why you're going to see more number of VNIs. So this is one of the VNI that you would take a look, like 67585 that has been created. And similarly, this VXLAN should be created on the ESX size level, right? That is the way like how things works out. Yes or no? Because ultimately VXLAN will be not created on NSX-T managers. This you're creating over here and it will be pushed to the ESX size level, right?
Yeah.
So yeah, so let's try to connect to our boxes. Boxes allows me. So I just need to enable SSH services. Let me go to services, SSH. Yep. So let me start it. So let's go to ESXi. Now in ESXi, like when we were in NSXV, it was again a very difficult task to find out what is the logical switch. You need to really remember the command and you have to mug up that things. Personally speaking, I had like a hard time to really come out from a Cisco command line interface to the VMware way of writing the show commands. But now with the help of NSX-T, it has become more easy. So you have your own specific mode of NSX. So you have to go to NSX CLI. So you need not to go to the native ESXi way of writing the commands. So you have NSX CLI, you go back to the NSX layer of an ESXi. And there again, you can still write on get logical switches. Now, when you take a look on logical switches, do you see any logical switches being created like any VNI? I created, right? I just configured one VXLAN. Just something has got bad, like I'm not able to see the VXLAN, right? I just able to see some VLAN. Okay, that is also a logical switches, but with a VLAN ID. And there's a reason behind of it, but I'm not able to see any of the VXLAN. Can anybody can guess like why we are not able to see VXLAN?
The information is at NSX Manager.
It's there in NSX Manager, but still it should be pushed onto the ESXi level, right? Because if I'm creating, and if I bring the VM, if the VXLAN is not there, then how my VMs will talk to each other, right? There, the concept of realization state will come up. Right now, ESXi has not realized that I need to have that VXLAN. And when he will realize to have that VXLAN should be configured, or maybe manager will realize that ESXi should have that VXLAN. When any endpoint gets connected, right? If you have any VM which demands to have that very port groups to be connected, then only manager will push the configurations to ESXi.
Okay.
So this is one of the really good fundamental which came from Cisco ACI, where like wherever it is required to do the config, there only we will push it. Unnecessary, why I'm going to create and do unnecessary number of config pushes to all of the ESXi. So it's basically a declarative mode of doing the config in NSX-T. So that's the concept. So what I'm going to have, like, let me just go to one of the Ubuntu. See, these are my GPU pod. Just see if any of them. Yeah, so this is in that ESXi where I have logged in right now. So what I'm going to do, let me go back and do edit settings. And I'm going to connect that VXLAN. So in T side, you can't really map any VM. It has to be done by the vCenter administrator. So this is the same way. You have to select the network, customer number 1, segment 1, hit OK. The moment I hit OK, what my NSX manager will realize that there is one endpoint wish to have connections to that VXLAN, then I will try to push that VXLAN to that ESXi. So now if you see go at logical switches, boom, we have that VXLAN. So you need to understand this part, okay? This is more important. So whenever we troubleshoot it and when you see that no VXLAN is there, there is something bad in NSX, no, it is pretty smart again. Cool, so this is one. So let me just check what configs that I have. So this Ubuntu is doing some testing. Let me see, I have config. I have an IP. Let me just write an config 10.1.1.3. I'll just if it is Ubuntu 3, so I'll just write on the fourth octet as 3. Okay, so if I do have 10.1.1.3, that is mine IP. Yep. So what I'm going to have another VM. Let me just move this. It is in Ubuntu 1. Let me just try it on an IP address. Config emails 192 slash. Okay, so I do have these two IP. So can I ping 10.1.1? I should be able to ping myself. Okay. So now if I have put them into the same VXLAN, obviously we can communicate, right? So if I go and try to ping to 10.1.1.3, can I ping? I don't know, we can't ping. What could be the trouble? So obviously from a troubleshooting point of view, what I would be seeing, this is connected to this ESXi. Let me just go back to this guy. Let me start it. I'll just try to connect to it. Root. Okay. The host name is bad. Okay, so this is something. Okay, no worries. What I'm going to do, let me just move this Ubuntu 1 to 0.2. Just migrate it. Let me just track the side. I know that host is bad somewhere. I know that. So this is Ubuntu 1. And I would like to go to now. The question is that why I'm not able to ping. And in order to do the V motion gates, we have to actually connect that VM to that port group, right? We haven't connected that. So we need to go back to the VM. So let's go to Ubuntu 3. Ubuntu 3 we have done. We need to put Ubuntu number 1. Okay. Right. Okay. Some common sense. I'll just write on the IP. I'll try to ping 10.1.3, which is mine. And if I try to ping 10.1.1, so what happens? So I'll try to go to 10.1.3, which I can reach. Cool. So we are able to connect to each other via two different ESXi. Cool. How are we going to identify that things? So again, what will be helpful? It would be your ESXi that will be helpful. So I just written logical switches. I would be able to see that, okay, one of the VM is connected there. But there are many other commands that you can really go through, like get. And if you will try to look out to logical switches, logical switch, which logical switch? I would go with this VNI. And if I take a look on op table, we would be able to see that there are two sets of IP address. That is 10.1.1. There's another one that you can just ignore right now. This is all because of another VM might be like connected to that very interfaces. But again, we are able to learn the MAC address on that construct. So this is one VXLAN without any IP subnet. We have not defined any IP subnet on the NSX layers. So it's just a stretch network. You put your VM, and on the basis of the IP subnet, you will have the reachability, and they will be single a broadcast mode. So think that there's a single VLAN extended everywhere. So that is one logical switch. You can even look out to the hardware VTEP table, which will come into the pictures when you have any kind of integration with Arista switches, where you can actually see what is the VTEP table that is being created from any hardware boxes. But I'm more interested to see MAC tables. What are the MAC tables that you would be able to see? So you would be able to find out that when I'm going to send the traffic, this is the outer IP of the ESXi. So this is the VTEP IP. So with the help of load sharing, remember that we have two VTEPs on the top. So it's going to use any of that VTEPs on the basis of source MAC address load sharing. Makes sense? Any questions up to this moment? So these are the verification command that you can use it. Ultimately, this is the idea. Any questions? Otherwise, I'll move to the another topic. Then you have VTAP table. What are the VTAPs that you have? Yep, that's the VTAPs. So I just seen that my remote guy is 15 and the local guy is 24. So what are these guys? These are my ESXi boxes. So if you would go back and you will see the VM kernel adapters, the 11 and 24, I might be something 39 and 40. Okay, cool. Any questions? So then I'll move to the logical routing part, which is more interesting topic. All right, so let's move to the next topic, which is logical routing. What it does mean, let's try to understand more in detail. I would say a little bit confusing topic, but we have to really adopt this model of the networking. Okay, cool. So let's move to the next one. We have a logical routing option, which we have been doing. It's not like that we have been not doing in our current environment, but we were using edge appliances so to do the routings. So in our current environment, whenever we have enabled the routing, we have different sets of VXLAN. So this is one VXLAN, another VXLAN, and we have one edge on the top, which will have one interface over here and one other interface over here. And then it connects to any of the uplink devices, which could be any firewall, which could be VDOM, could be Palo Alto, could be anything, or it could be even our internet gateway networks. So this is the way that we were constructing VXLAN, and on the top it was a VLAN always, or it could be a shared VLANs. But now we need to understand some basic logics. What happens with NSX-T? What is the meaning of tier 0 gateway and what is the meaning of tier 1 gateway? So on the basis of their properties only, we can construct any customer's environment now. So the first and foremost properties that you need to always understand, tier 0 will be always owned by the provider. So who is the provider? Like I'm the provider, right? In VCDs also. And customer will take the role of tier 1. So this is the way how in any service provider things works out. But again, as we are in a managed services, we basically take down both of the roles. We actually handle every aspect of the networking. So idea is that there would be a big router on the top that will be called as a tier 0 router. And then down under, there will be one router called as a tier 1 router. Now remember that I'm talking about a gateway and router concepts. Right now, I should be coming and telling that this term is called as a gateway. So this is tier 0 gateway on the top and tier 1 gateway. So this is one, you can think that one customer. You can have another tier 1 that could be for another customer. Okay, so that is one set of logic of designing it. Or maybe if it could be for a single customer, they can create this as a test environment network, or it can create as a production environment network. Now, the benefit of using this kind of networking is to have a same set of subnets, even onto the production side and even on the test side. Like in test, they have 10.1.10 network. They can even have the same network over here. That's the real benefits. Now, question will be coming up, then how we are going to reach out to test and dev or to the production separately. That's going to be done by the help of NATing. Like if you have to connect to test, you need to go to this T1. If I have to go to production, then you have to go to this T1. So that actually makes customer to not change their subnets if they want to have a bed of test environment and even for the production environment and even for the dev environments. So this construct tier 0 will be handled by provider, and you will really understand this real meaning when we will go to VCD. In VCD, we will see that tier 0 will be owned by us and tier 1 you can give to any organizations, because there we will see the concepts of VDCs will come into the pictures. Now, on that basis, if I go back to the next term, what we can do with tier 0. Tier 0 can only have BGP routing, and obviously it can have a static routing. I'm not telling that it can't have. So tier 1 can't have BGP. It can only have tier 0. If I'm talking about tier 0, can only have BGP protocols that can be enabled. On tier 1, you can't do that. Now, obviously, when you have a BGP options, obviously you would have concepts of ECMP so that you can have more redundancies in your environment. So we'll see that how many number of multipath that we can have with BGP. But obviously, you have to enable that feature of multipath even from your uplink boxes, because by default, BGP won't be a multipath when it comes to the resiliency in the traffic switchover. Now, in tier 1, again, it does not support ECMP. It is a single construct which will be there. We'll see the major things in the upcoming slides. Tier 0 is only the boxes which can have a north-south networking. Even it can have east-west. I'm not telling that it can't have, but tier 0 is basically connected to the physical network. Tier 1, you can't connect to the physical network. So in our case, when I have to terminate the edges, edges will go to our firewall on the top, same way where like you can only do tier 0 with that, not with the tier 1. And basically tier 1 is basically for our east-west traffics. So east-west traffics will be handled by tier 1. Now, for having a tier 0, you must have an edge cluster. Now, what does it mean? It does have a very great meaning, guys. If you just compare the things with NSX V, in V, we have to always instantiate a VM. Like if you might have seen in VCD, whenever we try to create edge, there would be one VM appliance that will be created, one will be active, and one will be standby. So the active one will get connected to your firewall on the top. Same thing happens with tier 0. But when you compare with V, in V you can have active and standby. But with NSX-T, you can have multipath. So obviously you would have more the number of the options to have more number of active edges. So basically that will be defined with the help of an edge cluster. So you'll see that there will be multiple edges that can be in a single cluster, and you define that this is my tier 0 gateway. So any of the edges will be active. Any of the edges will be active, and that will make our north-south traffic to be successful. But when you come to tier 1, again, it depends. If you do some sort of service insertions, okay, if you do some sort of firewalling services or NATing services, then you would need some cluster. Otherwise, this can be without any cluster. So in a very simple language, if I would like to say that tier 1 is very equivalent to a DLR concepts in NSX V, and tier 0, you have to think it as an edge devices. Now question will come up like tier 0, can I connect directly any VXLAN segment? Yes, you can do that. Tier 1 will always connect to tier 0. A tier 1 can't connect to the another tier 1. That is not a possibility. It has to go through tier 0. Okay, cloud theory. Let's go and understand some another aspect, guys. Okay, I know the topic that I just covered out now. We will see with our way of doing the implementations. We'll see. There are many other properties behind of it. Now, whenever we talk about in NSX-T, we have a two tiers way of doing routing. One is called a single tier routing or could be a multi-tier. And that's why I was telling that a tier 0 can also connect a VXLAN directly. And then it can connect to the physical routers. And in multi-tier, you will have an option to connect to tier 1 to tier 0. Now, what will be the real benefits of it? I think we have explained that part. Okay. Again, it's going to be a good way of doing the microsegmentations also in regards to the gateway firewall. Remember that, not to the microsegmentations, what we do with the help of DFW. It would be on the gateway levels. So whenever we tell it's a single tier routing or multi-tier routing, you have to think this construct, that there's a tier 0 connected to VXLAN, and if it is tier 0, that is connected to tier 1. Now, as I was telling, tier 0 can only connect to the uplink network. So when you see that, when I have a tier 0, and if I have to enable the uplink routing, I need to have edges. Okay. And that can have a shared VLAN, or else it can have multiple sets of VLAN. It depends upon your rack topologies. If we want to follow the more redundancies from a per rack basis, obviously we will have 4 sets of VLANs. But remember that this edge node will be behind of an edge cluster. The another thing that you have to also understand, a tier 0 can sit on one edge nodes. You can't have the same edge cluster to run the another tier 0 of another customer. No, you can't do that. Same way, same concepts what we had in NSXV. Okay, now next thing. This is more interesting now. We'll see there are 2 types of gateway components. Though like I just mentioned that tier 1, you just need to think as a DLR, and tier 0, you have to think as an edge. Maybe I wasn't very right on that statement. Now, you have the next thing, which is called as a gateway components. The gateway can be of 2 types. Now, this could be a distributed router, or it could be a service router. Now, whenever we need to do any sort of east-west routing, that will be defined by our DR. Like I just no need to have any services like NAT, load balancing, and many other things. I can still go with DR concepts. I need not to have any SR component. Now, whenever you have a DR, DR doesn't need to have any edge node to be instantiated. But whenever you have an SR, remember that you need to have an edge cluster. It has to map to it. Because obviously, these features of NAT load balancing will be created on the top. It can't be done on the distributed routers. So as I was telling, DR will be spanned all across to the every transport nodes and edge transport nodes, but SR will be only created on our specific edge cluster. So another language, like if I want to make it more simple, if you have a tier 0 with uplinks, you need to have edge cluster. But if you just need to have just a basic east-west routing, then in that cases, you will have a DR component, distributed routing, nothing else. On that basis, if I try to understand this logical diagram, when I combine both DR, SR, tier 0, tier 1, then you have to visualize the diagram in this way. Like this is the network construct, and this is the physical construct. So whenever I have a network construct where like a VXLAN segment A and B are being connected with a single tier 0, whenever we create 2 VXLAN and connect in this way, what you have to think about? You have to think about that there's a DR instances of tier 0 gateway that is being connected. But if I have to connect to uplink, obviously I have to connect anything on the top so that I can actually do the north-south routing. Then in that cases, I must have SR instances. But SR instances where it will sit on the edge nodes, and the DR instances where it will sit on the ESXi boxes as well as to the edge nodes. So this is the way the flow the things will work out. So whenever we tell DR distributed everywhere, whenever we tell SR, it will be stuck only on the node basis, like the edge nodes. Let's make it more complex. Now, if I have a multi-tier meaning is that you have a tier 0, you have tier 1, you have another tier 1, and then it is being connected. So in this case, what you would see, you would have a DR instance of tier 1 also. So this DR instances of tier 1 will be spread across every ESXi and whatever the transport node you have. So it will be a DR instances for this gateway, DR instances for this gateway, and DR instances for tier 0 gateway. And later on, you have to have SR instances which will be on the edge cluster. So this is the SR instances. So basically, this is the thing which is being even very commonly present in any public cloud environment also. Like if I try to compare it with public cloud, we have a tier 0 concepts there also. Like in AWS, we call it as TGW. TGW is nothing. This is a tier 0, nothing else, which connects everything. TGW will connect to your VPCs. Tier 0, TGW will connect to your direct connect. TGW will connect to your internet. So think in that way. In public cloud, it happens in this way. And this was the concept which was like being there, like in VMware tried to bring that things in the private cloud. Cool. Any questions up to this moment? I know it's going to be not that easy to understand. You have to grasp that things in some time. There should be a question, why I have a DR instances? What is the benefit of it, right? Let's make it more interactive. Otherwise, it will be very boring sessions, I would say. So if I tell that it's a DR, why we have a DR concepts? See, anyhow, if I do have an ESXi, like I do have a couple of 3 ESXi, right? Now, if I have a VXLAN of this gateway and VXLAN of the another gateway. Now, usually we right now have edges, like I'm just making a comparison with right now the environment which we have edges. And if I do have a VM number 1 connected to ESXi1 and VM number 2 in ESXi2, and let it with this edge is on this ESXi. So usually how the traffic goes, you would always see that the traffic will go from this VM to the edge, and then from edge it goes to ESXi2. So basically the traffic flow will be going from this ESXi, go back to him. So there will be a lot number of east-west traffic. But with the help of a DR as a component, what you're going to see, you will have a distributed router even in the same boxes. So you will see the ESXi can send the traffic with each other. You need not to send that traffic to the SR instances or the VM of the edge VMs. And the beauty will be again what, when this second VM sits on the same ESXi, the traffic will go within the ESXi hub. You need not to do and send the traffic to any router on the top, like which is in our case is an edges. So this is the real benefits. Now, if I move ahead, what is this? Multi-tier SR on tier 1 gateways. Why I want to do SR on tier 1? I've been doing SR on tier 0 for our uplink routing. But why I'm doing SR on tier 1? Any idea? Because till now, I was keep on telling that SR is basically for our routing, like north-south routing, right? And DR will be spread it across everywhere. So what we do basically from DR to SR, we try to send the traffic and then it goes to north to south. But why we have a tier 1 gateways with SR? What is the real benefits? Any idea?
Firewall.
Correct. That could be one thing as a firewall, but if we see the things from a service provider point of view, you would see there's a complexities that will come through. Now, I would say if we have experience with OpenStack, then we can think in that way. Like usually OpenStack, whenever we have a multi-node installations, like multi-node meaning is that one set of services will be on one boxes, neutron services will be on another boxes, storage service will be on the another boxes, and we try to club them, right? And we try to create a private cloud environment. Now, the same thing you have to think from a network point of view also. So what I mean to say that whenever we try to do any network functionalities, so we try to make out a differences there. Like one will be for north-south routing, nothing else, right? Then we will have some construct only for NATing functionalities. Maybe we will have only for firewall functionalities and blah, blah, many things. Even this can be differentiated with a customer basis, like a customer has a lot number of NAT traffics, okay? So I will try to create a separate edge cluster only for NATing features for that customers, or maybe for firewall, or maybe for the load balancers.
Oh, it's for to enable multi-tenancy?
Correct. And that is a true definition. Why like NSX-T was like V was changed to NSX-T. So to give the true multi-tenancy features on your private cloud. Because with V, creating a multi-tenancy up to an extent of routing we were doing, but again, we were ending up and creating this more instances of edges. And that is the real problem with our cloud right now. Right now, how many edges we are handling? If we have a number, it is more than 600, I guess. Do we really require to handle that number of things? No, we don't require that. Just for the sake of telling that, okay, if some microsegmentation we are doing, it's just not an accepted answer from a network point of view. Because multi-tenancy, it shouldn't be on an edge basis, rather it should be on a DFW basis. But when we come to network functionalities, then we try to think that what is SR instances. So when I told that if it is north-south routing, then what kind of routing we will be running? BGP, right? Now I'm going to run BGP with 2 nodes and creating an active standby. Is it acceptable? I don't think so. Right? It's acceptable way of designing it. It must be active. And not only one node, you should have around 8 nodes, which is the maximum number. Even I've seen customers doing automations on that. Like if 2 nodes are there, if it sees high CPU utilization or more number of traffic that we see, the another edges will be instantiated automatically. Okay, so this is one kind of use cases that we can think about. Now, why I was telling we should have separate NAT and firewall, because remember, and think about the previous slide, I told that tier 0 can have ECMP, but tier 1 can't have that things. It will be always active standby. And that's why we were not able to run BGPs on this part. I'm telling we can run, but it is not an accepted way to do that. So if I do have an active standby, I can run what? I can run NATing services, firewalling services, load balancing services, which we have been doing that. But obviously for load balancing, we have another methods now with a VMware solution of AVI, which instantiate service engines. It depends again. We can really explore that deeper. But again, if I'm talking about T, you have to see the things from a service provider point of view. That's going to give you the true multi-tenancies there. So again, there's a lot a window to discuss about it, like how we should do the edge on the top, how we will do the scalability things, and many other aspects. So on that basis, if I go back and try to understand, see, I would say the traffic flow won't be that easy to understand in one shot. You need to take some time. I just want to show the real view. I don't want to really make out that just a VXLAN and VLAN and then we are doing routing. That is not the understanding.
Could you possibly do, a comparison between the flows right now with the flows that you're talking about and highlight the differences that way? Or
okay, yep, sure.
For example, if you have like just as an example, like two VMs on different hosts, or two VMs, on separate network subnets, are just a few different kind of examples of the flows that the way traffic flows currently versus how it would flow, using T0 and T1 routers.
Absolutely, I can do that. Let's try to take, yeah, I'll take this window. So right now, if I think there's a voice coming up like a voice, everyone mute. Yeah, thank you. Okay, so now if I do have same scenarios, like I do have 3 ESXis. Okay, I'll take 4. I do have a VM over here, VM number 1. I do have a VM number 2. I do have edge 1, and that is active. And we have an edge 2, that is standby. Now, obviously, in this rack, we will always have a VLAN by which we will connect to our firewall on the top. That's our construct, which is there in our network design. So if I'm introducing concepts of SR, SR basically means uplink routing. So uplink routing meaning is that the static routing that we are creating between active and active edge and the firewalls. Similarly, we have another features. We basically use gateway firewalling depending upon us. We have a set of firewalls over here. We also create a NATing. So we have NATing features. So you can actually do a SNATing, DNATing, depends upon us. And many other things, like maybe we can do load balancing. Similarly, like some of the customers, and even like in our internal services, we have been using edges as a load balancers. So you're basically making one edge to perform each and every task. So if I go first with uplink routing, right now, what is the availability ratios? It is 1:1. Like we have only one edge, which is performing the static routing. The another edge is underutilized. We have been not using it for the data uplink. And do we see that in any cloud we have a VM just sitting idle, okay, utilizing our CPU, power consumptions, cooling factors unnecessarily? No, it's not good, right? So I have to use it. I have to make it as an active kind of things. But again, with V, we can't do that part. Or maybe if we can do, but again, up to what limit? Up to only 2. And I'm talking about only uplink routing, okay, nothing else right now. Now think a situation where like a customer been telling that I'm just pissed off with your performance. I'm not able to see the edges being performing when I'm doing the routing. Like I have a huge flow of traffic. So in that situation, this edge, we basically do what? We try to increase the CPU of it. Basically, when we increase the form factors, it goes from like 2 CPUs to maybe 64 CPU. You're basically increasing CPUs, but you never ever know what's happening under the hood as in like a service provider, because for one single customer, you might have increased it. and unnecessarily it's being like wasted. Okay, that could be one aspect. Again, the same thing, you are doing a gateway firewalling on the same boxes, NATing, LBs. So you will end up in a situations where like you would overutilize your edges, or maybe you're just hanging one another edges without any uses. But I'm talking about NSX-T way of deploying and making the design in a better way. So if I tell same diagrams, okay, I just took like a very basic diagrams right now, where I even like went through the DR routing, like VM1 want to talk to VM2, it has to go through the edges, even for the east-west routing. Okay, so that is another part. Not only uplink routing, even the east-west routing is taking edge. Now, if I try to visualize the same thing with NSX-T, I do have another ESXi, right? And just don't think that the edge is as sitting on an ESXi. Always see edges as like another ESXi. I'm again repeating, don't see edges as sitting on an ESXi. See edges as an ESXi itself. So I'm talking about an edge 1 over here, edge 2 over here, okay? That is only and only doing the north-south routing. So on the top, you have a firewall, okay? And you're doing a BGP routing with both of the boxes. And I'm not telling that BGP you can't do with V, you can still do with V, okay? You can still do that things. But T, yes, you can do. But only the trouble that we had earlier to 3.1.1 version of T, that we didn't have the support of OSPF, but now it is available. But I'm talking about a situation where you have a VM number 1, maybe VM number 2, VM number 3, okay? And let it be these boxes need to talk to each other. So in this case is what you have. You have a DR on the top. This DR will make that traffic to go with each other. Same way, when I have to do any sort of SR services, like a NATing services, so we will instantiate another edges like edge 1 and edge 2 only for NATing services. And remember that that is not for a particular customer. I'm talking about from a service provider point of view. Like if we have a big customer and does have a lot of NATing, obviously we will have another cluster created only for it. But I know that we have only ample number of NATing services. So what I will do, I will try to create this edges always closer to the ESX size wherever the VMs are being presented. But these edges is and has to be connected to the racks where I do have my uplink devices, the physical devices. Now, if I see that there's a lot number of NATing services, obviously from a data flow point of view, though you would see that you will have the traffic go from edge 1 and 2. Remember that you can have more number of edges. It can go up to 8. This traffic will go to the NAT edges and then it will go to the VMs. But this guy is only and only doing what features? NATing as a features. Same way, it works with LVs also. Right now, even in our current environment, what we have 2 boxes of F5s. One is active, one is standby. All traffics are hit, like it's getting a hit onto the one F5s, and this guy is being utilized, and then the traffic goes to any of the edges. So same thing we can also do, but in a distributed fashions. Okay, so I'm talking about a situation where like tier 1 SRs will be on the basis of the services, like NATing as a service, you will have gateway firewall as a services, then similarly load balancer as a services within your NSX-T. But again, a question will come up like you're running 8 nodes and just for one customer. No, it's not like that. These edges, what I have prepared, it will have services of that customers. Remember that containers and the Dockers will be running for each and every constructs. And obviously, from a monitoring point of view, we need to monitor the edge node. Okay, this is being utilized highly. Okay, so I can bring more edges into that. Just like an OpenStack services. Just like if you have experience on OpenStack, we do in that same way. So did you understand in that aspect? But again, from a traffic flow, there will be a huge number of changes in the traffic flows. If I have to really bring that, just creating some diagrams. Like I just constructed some basic diagrams right now. I have not included tier 0 till now. Like, yeah, this is the one. Like you have only tier 0 DR or traffic moves from one VM to any edges and how it goes to the uplink routers. So see, the whole idea of NSX-T is that to minimize the east-west routing, that is one thing, and make it a true physical device which will have more sense to connect to the physical network, not to only be like a virtual networks. I think I talked more like 3:30. I was like expecting that I will do some labs there. Okay, so understood, Stan, everyone?
Yeah, thanks. That certainly helped.
All right, so that's the thing. Now again, like from a logical router interfaces, how things will see, we will see this is tier 1, this is tier 0, and then it goes to physical routers. You have a VMs present, then what we call as what different concepts, like constructs over here. Then obviously how you will create an edge nodes. Edge nodes will be not same as like what we were creating. This is going to be a huge different over here. Like right now we create an edge on application basis or maybe on customer basis where the VX line will be connected there and then we have a VM. No, it's not going to be like same. We will have a big boxes of edges and there the containers of the customers will be running there. Now, what will be the design of it? You will see the edges will be like edges this time can be a bare metal. Okay, that's the major differences that I would see. Edges can contain on a bare metal or even it can run on a VM basis. So if you have if you have supported a bare metal, then you can, yes, you can run the edges on a bare metal, just like how we run our routers. Same thing you can do that. But now, if I'm talking about from a VM point of view, when we create an edges this time, if you really compare with V, in V you will see there will be 10 interfaces, just like in any VM. VM has like capacity of having 10 interfaces. But over here, the edges will have only 4 interfaces. I'm talking about the VNX. So why we have that 4 VNX? If you can see in the diagram, the first one is for the management. And that's going to give us a really good benefits in the terms of troubleshooting and connecting to edges. Right now, to connect to the edges, what we do? We go and console to it, and then we try to troubleshoot. But we will have a separate network for the management networks. So with this network, it is going to get connected to the controllers, and it is going to accept whatever the APIs and the configuration changes. And even the same management network, you can connect and do SSH, and you can do the troubleshooting also. Next one is a TEP. And this is the difference that you're going to see. We are not terminating VXLAN directly over here. We are sending a TEP. So just like in ESXi, you will also have a TEP interfaces. And this TEP can be mixed with your VLANs. What I mean to say that if I do have an edges, so this edge is a VM. One will be for the management network. One interfaces will be only for TEP. by which it can connect to all your ESXi. So ESXi, when he was sending any temp traffic, the unique tunnel traffic, earlier ESXi to ESXi, they were talking to each other. Exceptions will be there, like if you have Arista, if you are doing hardware VTAPs, so you can have another boxes which will have a hardware VTAP and then usually communicate to each other. But this time edges will also get tap traffics. Because you never will know like for which customers or for which T0, T1, you're going to create the containers into it. So that's why like it's going to have a tab. But again, for the redundancies purpose, again, you can have more number of tabs. Okay. And you can have another interfaces by which it is going to contact or connect to the physical network. That is through the help of VLANs. So it's going to be a containerized solution of the networking right now. Just visualize in this way, edges that we created just now, we create as a VM instances, but now these edges will be like a containers. As simple as that. So now what you're going to see, again, from a design aspect, you can make all that tree as a VXLAN as well as VLAN based, and then you can connect to the switches. This diagram is basically before, I would say 7.0, but again, it depends upon you, how you want to really construct it. So now on that basis, let me just show you how we constructed any edges. And remember guys, this same thing, okay, you need to really visualize when we will be doing with vCloud Director. And vCloud Director won't be a very straightforward one until your concepts are not very clear about tier 1 and tier 0. Because if I do create anything over there, and if I tell that it is multi-tier topology, so you need to visualize, okay, tier 1, and then we have a tier 0 connected. And in VCD, we don't have an option to connect tier 0 directly. Okay, that's why I'm more emphasizing that you should come into the thinking of multi-tier topologies. So to create an edges, you have multiple methods. You can have a bare metal, and you will have an ISO which you can run there, connect, define an IP address, and connect to the NSX boxes. That is one of the way. So this will have to have a DPTK approved NIC adapters, then only you can really do that things. Usually customers do for getting a high performance. So usually when we are dealing with the NFV solutions, then like customer goes with the bare metal as an edges. But if we are like in a cloud environment, we can still go with the VM based. It's fine. But again, it depends upon the experience and how much traffic that we are expecting from the VM levels. So as I was telling, ESXi as in fabric, it will go to the nodes. And if I'll see the vCenter one, these are my ESXi nodes, which I have created already. But the next one is your edge transport nodes. So you need to create that edge transport nodes. And if you will see, we have NDVS that is being created. Okay, so another major differences. You have a DVS, right? In these, like on a ESXi, you can have NDVS before 7.0. But on edges, you will always have NDVS. So do you need to do any changes there? No, you need not do the changes. It's just a one-time of configs. So when I'll take a look on tunnels, so these are the tunnels that is going to be created all with your all ESXis. So this is whatever the number of ESXis, these are the tunnels that is being created. Just like another ESXi, think in that way. Same way, if you will take a look on monitor, and look out to the monitoring, like how is the system memory, what is the utilization, and all those things. But obviously, we need to pull out a lot of information from these edges, like what is the traffic, utilizations, and that can give us more idea how we can do some sort of automations if that's required. But yeah, I would say like we should not really try a lot, but again, for research basis, yes, we can do that. Now, if you will take a look at the backend interface, there will be three interfaces that will be created: FP H0, H1, and H2. This is like a VXLAN and VLAN capable, and we will have H0 that will be only for management. So this time, like when we are going to construct the VTEP of NSX-T, we need to consider the edges also as a nodes, not only ESXi. So we need to little bit increase the number. But obviously, we will have scalability. I have not checked it, but again, we need to really think about it. If you would see the same pattern like I have created, like I was just doing a lot of testing, like how we would have a T1 dedicated edges, T0 edges. Then if you would go to networking, we will have tier 0 gateways, which has been running like this tier 0 in a shared concept, in a SaaS services concept, in a VRF basis. So I was testing those parts. And tier 1 again on the services basis. You can really make out the differences there. But now what I'm going to do, let me go and show you how to create the edges. I would say like before 2.5, you didn't have this option to create edge from your manager. You need to create a VM, put an ISO, then match your thumbprint and many other things. So blah, blah, many things. Now, it depends. Now, like let it be if I have a customer, and let it be like, I should not say customer now. I would be saying we have services that has to be instantiated. So I would need an edge cluster. There I'm going to put one of the edges. I can put many number of edges, but I'm going to just put one right now for the sake of time. So I'll write down edge 01. That's 01 as a name, depending upon what is the sizing. So you can have 8 GB of RAM, depending upon what kind of traffic that you're going to expect there. If I have to construct tier 1, I would really go with 64 GB, like in any kind of production. I'm not go with a smaller one. But again, you can change the form factors anytime. Again, you have a reservations option, like you want to create more number of chains within the edges. You can increase it, decrease it, depends on that. All right, next. Now it's going to ask me what should be the password. Just put a notepad. I'm going to write down the password. I have to copy the same password again. I don't want to write down multiple. So you want to allow SSH? Yes, I want to allow. If you are not allowed, you can do that things later on also. Root SSH, this is basically for your, and this is again root SSH, that's basically for your troubleshooting, look out for the logs and the things. Audit user, that you can create it next, like a different one. I put next, where you want to really configure it. So obviously you should have a compute manager if you are deploying it on a VM level, but if you are deploying on a bare metal, it's not required to have a compute manager, but there's no any reason that you should not have a compute manager. Where you will be configuring on my cluster. So again, remember that if I'm designing anything, if I'm planning to have a tier 1 edges, so I will always put into the same cluster where my VMs are sitting. But if it is a tier 0, only for north south, I'm going to put into different track where like my firewall and the physical boxes are there. So that's one thing from a design. Where you want to instantiate, you can instantiate anywhere. Data store, just use GPU. Yeah, this is the one. Let next. I'm going to define a static IP. Just 2 IPs left. /24. And yes, you have to map your management network. So I would say this is my VLAN 6, save it. It's fine, you can go ahead. Just let me make sure that this IP is not being used anywhere. text. Yeah, so now this is the very interesting thing. This is asking you that now you have to create a switch, right? What does it mean? This is the way like where you have to map your F-ith0 to F-ith2 interfaces. So when I have an edge, I do have 4 NIC cards, right? So the first NIC card we have already connected to management network. But another 3 NIC cards, how you would connect your physical infra. Remember that it is going to be contained into a ESXi. On ESXi, you will have a separate set of uplinks, like you say, a physical uplink. So how are you going to map this physical uplink with these VMix? So obviously, it's going to be on a DVS from an ESXi. So I will have some port groups which will map to these NIC cards. But remember that on the edges, you will have your own DVS that is going to be called as NDVS. So always think a situation where like you have a nested ESXi and think in that way, it will be more easy to understand. But if you think like, okay, what is NDVS? How these things is being connected? People will get confused. So if you have created any kind of nested environment, think in that way. So this NDVS is the option, and there we are going to map these NIC cards. So if I'm going to go with, you can define any name, doesn't matter, because it's not going to be viewed on your vCenter levels because it is within the boxes of edges, and the naming convention could be anything. But again, if you are going to think about some sort of automations, make it no problem. Now, the next question will come up. What is going to be the transport zone? Again, in the previous sessions, we talked about what is transport zone. That is basically a container. I would say it's a construct up to where like any entities will have the boundary. Okay, so it's just a boundary. So if you would see, I have created one for VXLAN. Obviously, that is required because if any ESXi is going to send any VTEP, I need to be a part of it, right? And I have to have a part of a physical network. So I would have my own construct of VLAN so that I can connect to the physical networks. But remember, I could be not a part of a VLANs which is being having with our ESXi. Like in this DVS, I can have some VLANs which I need not to do that. Like I need not to extend that VLANs there because this is a DVS level things. So this is major differences while creating a transport zone. So I have already created an edge VLANs. Okay. And uplink profile wise, I have even created an uplink profile. If you will want to look out the things, you can check it out. It's an active. Again, you can go with active standby modes also. But it depends upon how you have created your uplink profile, that number of VTEPs will be created. And the number of VTEPs will tell that how much load sharing that you can do. So again, a design decisions that you have to make it out. So use IP pool. I have already an IP pool of my VTEPs. And then you have to map your interfaces. So what I'm basically doing, this interfaces I'm mapping to the DVPG, what it should be carrying it out. So in my DVPG, I must have which VLANs. Idea? Guys, question? Like on this DVPG, which VLANs we should have? I should have VTEP VLANs, and I should have VLAN, which will be on the physical networks, nothing else. Because this edges, we want to just communicate from a VXLAN point of view, and it gets connected to the physical networks, nothing else. But if you're creating this as a tier 1 for the SR instances, just to have like VXLAN, nothing else. You need not to go and consider VLANs there. So these are the design discussions, design decisions that you have to make it out. Now, very important point. Prior to 3.1, your VTEP should be on 2 different subnets. So I've written a blog on that, things like why it is required. You can probably check that part also. But again, with 3.1, you can have a bypass of it. Only the fact is that the VLAN should be created from the NSX instances, not from the vCenter point of view. So okay, that's the one thing that you can see. This port group, if you will take a look, I'll just go with the another hack of the process. What I have done, I have created another DVS only for edges. So ultimately the traffic will come from ESXi from this DVS as a VXLAN to this DVS, where like my edges are being contained. And then this port group, I have just allowed only my Vita VLANs and whatever the uplink VLANs, not any other VLANs. So this is a way how you can contain your VLAN propagations to any clusters. So go back, NSX, port group 1. And basically the configuration is same on every port, but just for the sake of best practices, I just made 3 port groups. Because you never will know, if you delete one port group, everything will be down. So it's always good to have same construct with the three different DVGs, and just finish it. So what's going to happen, wherever you have created, like you have defined that it would be created the edges, you'll see the edge will be instantiated. And remember that this is not an everyday process. You just need to create the edges, contain the things, and keep on onboarding your customers. What we have to play with, we have to play with the configurations on the containers. Basically on a tier 0, tier 1, where you want to put, where you want to actually attach to it. This is the thing that we have to explore. So from an infra point of view, I'll just create an edge. Okay, I'll tell that, okay, this edge is only for this kind of customer, this edges will be for this kind of customer. And then maybe from an automations, we can define it and it will be good enough for the for onboarding any customers, and maybe we can delete whatever. So that's the thing. So what we're going to see now, this edges will be coming up. What was the name that I've defined? Edge 01, yeah, this is the one. So it's being like doing a OVA deploymentations. It is going to be created. It is going to be programmed. And then let's see what's going to happen. But again, for the sake of timing, I have already got my edges. So some of the edges. So this is one of the T0 edges. Just don't go with the naming. Naming could be different. And if I go to this edges, and if you will take a look on my configs one by one, because I don't have much time and I have another meeting at 4 o'clock. So maybe we'll try to continue in BCD lectures. So in tier 0, if you would see, I have some set of tier 0 configs. And remember that these things will be coming as in containers to us. So if I'm going to go to the edges, and if I write on the same command, get logical switches, you'll see there will be logical switches being created. And you don't have to really worry about tier 0, tier 1 connectivity. All that things will be within the VXLAN. Like tier 0 to tier 1 VXLAN will be created, and that is system generated. And again, that subnet between them, it's again, you need to really worry about it. Though you can create your own subnet, but that's not required. Now, this is logical switches. Similarly, this guy's for logical routing. So if I take a look at logical routers, you'll see these are the logical routers that is being created. So these are what? These are container services of one of the routing, which is contained on one of the edges. So I have some of them, and what is more important, the naming convention, whatever the naming that you have defined, by which only you can identify what kind of routing instances and what is the network and routing table is being created. So let it be, if I go with VRF0 first. So to go to any construct of container, you have to go and just write on VRF0, and there you can look out to the get forwarding. So this VRF0 will be common everywhere. This is basically for your VXLAN terminations. So right now I have these 3 IPs that is being on this edges, and map to 3 NIC cards. So that's going to give me a better throughput from a traffic flows. And obviously I have a gateway, which is on the top, which is basically for the VTEP configuration, nothing else. But if you have 2 different subnets or VTEPs, you just need to make sure that your routers will be capable to handle the VTEP traffic of their related MTUs. So this is the thing with VRF0, nothing much more extra over here because you get a VXLAN in this container. And then on the basis of customer-based traffics, you're going to decapsulate it, and then it is going to be contained into the related VRF, which is basically your tier 0 or could be a tier 1. So this is one of the example of tier 1 SR instances, and these are the SR instances of your tier 0 and even the DR instances of tier 0. Because remember, DR will be distributed all across tier 1, depending upon what kind of mapping you have done with the help of your logical gateways. So if I take a look on, let it be this customer, VRF1. And if I take a look on gate forwarding, there you will see that these are the network that I've connected on the top. What network I'm learning from backend. This is the backend network, which is connected to my tier 1. So again, this is the inter-transit networks, which is there. So again, I had not defined that things. So this is more about the things which you would see. Obviously, I would suggest like let's go for the next session. Maybe when we will go with VCD, I will try to show you the traffic flow. But again, from a theoretical point of view, you should be very confident that how these constructs are being made. Again, you have a better way to really do that things. You have a topological view that you can really explore, as well as from a plan troubleshoot basis, you can go and look out to the trace flows. So just for a quick overview, if I have to create a tier 1 gateway, let me just create I think we have already created one segment. Let me create another segment. So write on customer number 1, segment 2, and there you will see the option of connected gateway. So in which gateway you want to connect? So I want to connect to tier 0 directly, or I want to connect to tier 1. So I would say that, okay, let me connect to my one of the tier 1, or maybe you can create it later on. Transport zone, I'm going to create a VXLAN, and this time the gateway will matter. Earlier we have configured without the gateway because we didn't have any routers there. But now if I'm going to do this segment for routing features, obviously I need to have a gateway which is going to sit on the DR instances of any of the tier 1 or tier 0, depending upon what connected gateways that you're using. So if I'm going to tell that this is 20.1.2.4/24, I'll just save it. So do you think that the gateway would have been created? No, because I have not connected any gateway. Let me create another tier 1 gateway for it. So I'll write on customer number 1, to which gateway you want to connect. Like again, the upper level things, you have tier 0 gateways connected. Which edge cluster? Remember that I have 2 clusters, but the one that we have created just now, the system one, it is not appearing because remember this is edge cluster. This is not edge. So edge has to be contained into a cluster as like same concept as in ESXi. ESXi comes into a vCenter defined cluster. Similarly, edge has to be there in edge cluster from an NSX T point of view. So that's the thing. And again, obviously you have one thing that you have to really notice. You can set an edges who will be active and standby, but remember tier 1 will be always an active and standby. But tier 0 will be always active, but again, you can make it as an active standby, depending upon your SR services, what you want to instantiate there. So if I'm telling active standby in tier 0, then in that case, is the SR services like firewall, I'm talking about gateway firewall, and NATing. Then in that cases, you have to make it active standby. So these are the design decisions that you have to make on the customer's demand, how you want to construct your network NFVs in your NSX-T buildings. So I don't want to really go now, like again, if we go into the detail of it, you need to understand the traffic flows and other things, but this is the overview what you're going to see from a routing aspect. So any question, any comments?